So we've talked about our instance data variables. We've talked about our constructors. So now let's think about our getters and setters. Just like we were writing for any other class, we would want to write a getter and a setter for our new instance data variables. And for these particular variables, I probably don't have any meaningful validity checks to do. So I'll just take in the new information. Okay. Now, one other common mistake that I see sometimes is the rewriting of, get title, get num seconds, get price. We don't want to rewrite those methods because they're already there, right? We've inherited them from the parent class, so we don't need to rewrite them in this child class. They're already there. Even though they're not typed into this file, they're there, right? We've inherited them from the parent class, so I don't want to rewrite them. So here's our getters and setters. But let's now talk about other ideas for methods. So we're going to talk about overriding methods. So we think about those methods that we inherit. Well, we can also override the definition of those methods and provide a new implementation. So for example, if we have a method we inherit from the parent class, but we want to do things a little bit differently in the child class, what we do is we override that method. And what that means is that our new method will have the exact same signature, so it's going to have the same name and parameters as the parent's version, but we're going to change that implementation. So we're going to say, okay, the parent method did things one way, but we're going to do things a little bit differently. And so we want to override, think about that as replacing the parent's version of the method. Now, when we do this, we're going to use what's called an annotation. Annotations were not part of the original Java language, but they're a great addition. And annotations often start with the at and a capital letter, and then we have the name of the annotation. So this one's called @override. What annotations are is they contain metadata about programs. So they basically contain information about the code, and it allows you to put a compile time check on certain characteristics. What the @override annotation does is it allows you to ensure at compile time that your method header is correct. This is a really good practice. I'm going to encourage you right from the beginning to always use the @override annotation when you're overriding a method. And I'll show you in a minute what the benefit of it is. So let's take a look at the methods that we have inherited. So we have audio item. We've inherited all the getters and setters. We've inherited the toString, and we also inherited this play sample method. So let's say, okay, I actually want to do things a little bit differently. If it's a music song, I want to play maybe 30 seconds. That's my sample. And if it's a book, maybe I want to play the whole first chapter, however long that first chapter is. So we still want to be able to play a sample, but we want to do things a little bit differently. Okay, so if that's the case, then we'd override this inherited method. So this is the method that we inherit from the parent class, but we might want to do something a little bit different. So let's go into our audio music class, and we're going to override the method. So we're going to start with our annotation, the @ capital O override, and then we will say the exact same method header. So the exact same method signature, public void play sample, like that. So this is now saying that whatever code I put in here, it's essentially going to replace the version I inherited from the parent. So now instead of having this play sample method, I'm going to have a new play sample method. And maybe, as I said, perhaps I'll keep things parallel here, sampling the title, and maybe again I said I want to play 30 seconds of a song. Okay, so now in my child class, this is now the play sample method associated with audio music items. We have overridden or replaced the version we inherited from the parent with this new version that does something a little bit differently. And same thing in audiobook. So I haven't yet added my getters and setters into audiobook, but I will do that. I can have my override. I will sample the get title. Right, I can't just say title because it's private. I got to access it through the public getter. Okay. So again, I'm saying that, hey, I don't want to use the version of this method that was implemented in the parent class. I want to do things a little bit differently in the child class. And to do that, I have to override that inherited method. Now, the reason we use this annotation is because if I were to have let's say I didn't use this annotation, and I'm typing and I just make a little bit of a mistake. I make a typo in my method header, so I don't have the spelling of the method name be the same. Well, this isn't going to give me a compiler error, right? Because I can have a method called play simple in my child class. That's no problem. But now what I've got going on in my class is I've got my inherited play sample method and I've got my child play simple method. So I've got two methods, which isn't what I wanted. And that kind of error is actually really hard to track down. So if I use the override annotation, this will actually give me a compiler error because it's saying, hey, you're trying to override a method called play simple. Oops, sorry, I did a little autocorrect there that I didn't mean to. Called play simple, but there is no such method in the parent class, so you can't be overriding it. There's nothing to override. And that allows you to say, oh, there must be something wrong with my method header here. So let me look at that, and then I find, oh, that's my mistake. I've misspelled it. So that seems like a small thing, but it's actually really, when you make a mistake like that in like a simple misspelling of an overridden method name, it's very hard to track down that error. It can be. So using this little compile time check is a great thing to do. It will highlight an error if you make an error in the method header. It's also just good to alert your reader, someone reading your code, that, oh, hey, this is an overridden method. That means this method exists in the parent class, but the child class is doing something a little bit different. If I didn't have that, there's no way for someone to know by looking at this child class that that's what's going on. They might just think this is a method that I just wrote in my child class. They have no way of knowing this is actually replacing the parent's version of the method. So for all those reasons, it's good to use this annotation. I recommend getting into the habit of it. I know annotations might be new, but they're very user-friendly. You just put this little tag in here and kind of the compiler takes care of the rest. So again, overriding means we're replacing the inherited version of the method. Now, when we do override a method, it's because either we want to do something different, but sometimes we don't want to do something totally different. We just want to do what the parent does, but then we want to do a little more. So the way the method we just wrote, it totally replaced the parent version. It said, I'm not doing anything the same that the parent's doing. I'm doing something totally different. Right? I'm fully replacing that method, which is sometimes what we want to do. But sometimes we just want to add on to the parent's method. So we want the parent's method to run, but then we want to do something additional. Now to do that, we use, again, the super keyword, but we use it in a different way this time. Here we use super dot the name of the method. Okay, so the classic example of this is when we override the toString method. Often in the toString method, we still want to print out kind of the parent part of the object, but then we want to add on that additional information about the child. So I, of course, could override the whole method. And, I originally had printed out the title, price, and duration. So I could do that again. Right? But I'm noticing that, wait a minute, I've already typed this code before. And anytime I'm repeating code, I want to stop and say, hey, is there a better way to do what I'm doing? Because I am duplicating code that I've already done. And I always want to avoid duplicating code. So yes, there is a better way. And that better way is I can invoke the parent's version of toString. So I could say string parent string gets super.toString. Okay? And then I take that parent's part of the string and I add on to it some more information about the child class. Like the author, I'm sorry, we're in music item here, like the artist, and the genre. And then I return that whole string. Okay. So this is a way, I'm still overriding the method, so this method is completely replacing the parent method. But inside that method, I say, well, actually, I still kind of want to access the parent's version. And again, I do that with super dot the name of the parent's method. Okay, so even when we're replacing a method, we can always still access it in that parent class by using super dot. And this is very common in toString, because oftentimes, again, we still want to print out that information that described the parent, and we don't want to duplicate typing all that code. So we say, okay, get the parent's part of the string, and then add on to it the child's part of the string, and then return the whole thing. And I can do the same thing in audio book item. So again, I'm still overriding it because I am replacing that parent's version of toString, but I'm just adding on to it the part that describes the child part of my object. Now, it might be possible that your toString, you want to completely replace the toString and you want to have your child description be totally different from your parent description. If that's the case, you just wouldn't invoke toString. You would just write this method without it. But if you find that your toString or any other method is repeating code that happened in the parent, stop, right? We don't want to repeat code. And then think about whether you can invoke that parent version of the method and add more onto it. So we've seen two different uses of the super keyword. The first is to invoke the parent constructor, and there we just use super followed by parentheses, and we send whatever parameters go to the constructor inside. And the second is to invoke that parent's version of a method, and here we have super and then the dot operator and then the name of the parent's method, and then again followed by whatever parameters go inside. So two different uses of super. When you use super to invoke the parent's constructor, it has to be the first line inside the constructor. When you're using super to invoke the parent method, it can be used anywhere, and it can actually invoke any parent method. So previously I had mentioned that we could write this.getTitle saying, hey, get the title of the current object. We could actually also invoke super.getTitle. That says, hey, invoke the parent's version of getTitle, which, because I haven't overridden getTitle, is just the same version I've got in the child class. Now, it's not common to see that, but I'm just saying you can use that super keyword to invoke any of the parent's method from any method. It doesn't have to only be the method you're overriding. It can be any method that you inherit from parent. You can access it with super dot. Now, there's kind of a classic interview question about overloading versus overriding. This is unfortunate because these two things really have nothing to do with each other other than the fact that they both start with over. So I think people like this question because it confuses people and these are easy to get mixed up in your mind, and it's really unfortunate, again, because these concepts are really totally not related to each other. But because this is a common question, I have this slide here for you to reference. The basic idea of overloading is that you have multiple methods in the same class with the same names and different signatures, meaning different parameter lists. You use overloading when you want to have the same operation that takes in different inputs. Okay, so multiple ways of doing the same thing. Right? We overload constructors. You can overload other methods if the methods all accomplish the same task, but they take in different inputs to get to that task. Overriding you use when two methods are in different classes, one in the parent class and one in the child class, and those methods have the same name, the same signature, so same name, same parameter list. And here you use overriding when you want to provide a similar operation that has additional or altered functionality. So when you want your child class to do something different, or you want your child class to do something more to implement that functionality. Okay, so just keep these two things separate in your mind. Again, they really aren't related other than the fact they both start with over. So it's unfortunate they don't have different names because then we'd lose this question that is kind of a silly question anyways.